Okay, welcome to another Colin support video. This one is on, let's turn the mic on. This one is on not linear and nonlinear functions. Let's go. So it says, does the graph shown below represent y as a linear function of x? Well, a linear function means it has a constant rate. So as you increase x by 1, y is always increased by the same amount. So if you guys can see here, this is a curve. And as you increase x, it's getting steeper and steeper and steeper. The rate's not staying constant. So this is not a linear function. So this would be a no. It's a curve. The next one you're going to have is this one here. It says, could the table of xy pairs, let me turn this off so I can hear. Could the table of xy pairs have been generated by a linear function? So what you're looking for here is as x increases by 1, is y increasing by the same amount every time? So you look for the slope, okay? If it has a slope that's constant, then you have a linear function. So what's the change from 4 to 3? The change in the y value is -1. What's the change from -7 to -3? The change in the x value, it corresponds, will be +4. So the change in y over change in x, or the slope, is going to be -1 over +4. Now, -1 over +4 is a slope of -1/4. If this is a linear function, that change in y over change in x ratio must be constant throughout the entire table. How do I get from 3 to 2? -1. How do I get from -3 to 1? Add 4. So once again, you've got -1 over +4, -1/4. And then this last one here, how do I get from 2 to 1? -1. How do I get from 1 to 7? That's +6. Well, this is going to be -1 over +6. That's not 1/4, is it? So the first two instances have a constant slope of -1/4. The last one has -1/6. So the slope is changing. So this is not a linear function. Here you have a straight line. As x increases by 1, y is always increasing by the same amount. The steepness stayed the same throughout the entire relationship. So this is one straight line. This is a yes. It's linear. This one is a curve, right? As you increase x by 1, y is not increasing or decreasing in a constant way, right? As x increases by 1, y is decreasing. And first off, going faster and faster and faster down, right? Steeper slope, then more gradual, and then it actually reverses polarity and goes right up, right? As x goes to the right, y goes up now. This is a curve, not a line. It's not at a constant rate. This one, you're going to ask yourself, is the slope constant? So from -6 to -3, you'd add 3. From 0 to 1, you'd add 1. So that's 3 over 1, right? Change in y over the change in x. 3 over 1, that's 3. From -3 to 0, you'd add 3. From 1 to 3, you'd add 2. Well, this is going to be 3 over 2. Now, 3 over 2 is not the same as 3 over 1. So that means the slope is changing. The ratio of change in the y over the change in x is not constant, so it's not a linear function. So this would be B, no. Here you've got some kind of wave curve of some kind. Definitely not linear function. This is like I don't know, sine wave type of stuff, right? Where you're talking about radio frequencies and things. Definitely not a linear function, okay? A linear function has to have a constant rate. This is going down, then it's going up, then it's going down. The steepness is changing throughout the process. This is a curve. And this last one is also a curve, right? It starts going with a steeper slope, then it gets more gradual, more gradual, more gradual. This is not staying with a constant rate of change, not a constant slope. Constant slope is literally like a ruler, right? Straight line. So from this dot to this dot, it'd be a straight connection. This is not like that. This is a curve. This is no. Anyways, so that's how you do that, right? Look at the slope, see if the slope is constant.